Exactly. And that was, I wanted to unpack that anyway. So good you actually given the direction on that. Um, if you had to take a deep dive, the first point I wanted to unpack with you was about how we ensure reliability of the AI systems in production. And as you rightly said, selecting model is just one fraction, one part of it. But that's not everything. The more important when it comes to reliability aspects in particular is how you ensure the security, how do you ensure the overall reliability of the system, and building that harness around that is becomes incredibly important. And industry has shifted from the prompt engineering to now focusing more on harness engineering, right? So if would you mind unpacking that when you talked about harness, what really goes underneath? What are the key control planes organization should be thinking of to build a good harness?
Yeah, and uh, for when people talk about harness, they're talking about multiple things, and so it's just a catch-all bucket at the moment. And I think we need to start to distinguish what we mean when we say harness, because the harness could be, the various tools and memory types and things that you use in
Yeah.
an agent. It can be, Claude Code and Codex and Cursor are all examples of harnesses in their own right. But then when engineers start to talk about harness, they talk about the custom tooling they build, the sub agents that get
Mm.
called during invocation, and so there's that. There's those ideas, and then I've also seen people talking about harness in terms of the whole team infrastructure that sits around, the single individual engineers. When I talk about harness, or I typically talk about a meta harness because I like to think in
Mhm.
terms of whole teams. An individual is going to build the way they build, right?
Mm.
And if they some prefer VS Code or JetBrains historically, they pick their IDE. The engineers are going to build their own coding harness setup, and that's going to become their secret sauce, their magic. Like a Jedi building a lightsaber, and it's going to be unique to them. But the magic was never, if you look at Star Wars as an idea, we're enamored with the Jedi and their lightsabers, but that's just a tube with a crystal in it and some Force magic.
Mhm.
This is probably a bad example, but the Death Star. Now that is an architectural marvel, and
Mm.
it's a what a stunning picture of civilization level collaboration. And so I think really the power going forward is going to be at that sort of meta scale where we start to think about harnesses or meta harnesses. So some of the things you mentioned cybersecurity. There's obviously things like QA. There's cloud infrastructure. Marketing has a say. Legal, risk, compliance. They all have a say in how things get built. And models and coding agents are really good. I mean, really good. Right now, since December, and you had what was it, Opus 4.7 come out around December. They've been astronomically good at generating code. And since you've had various GVT models come out, and they're also exceptionally good. Now you've got Chinese models, GLM 5.2 and Kimi K 2.6, all very good at generating code. And so, like personally, I've barely written a line of code in 12 months. Like I've written code, of course, but it's probably down on that 10% range. And when you're doing green fields, that's totally fine. Like if I just put in a PRD or a prompt or something and have it generate some code, and I don't care that much around style or language or infrastructure or databases, it's going to churn out something that feels like black magic. And that's
Mm.
that's every man and his dog on LinkedIn who built Spotify. They're able to do that. But in terms of generating code particular to your organization, that's a completely different story. They don't know the model doesn't know anything about your organization. And so this is where we need to shape a meta harness around it to shape the outcome together that's unique to the needs of your organization. And so, one thing that I built was called the governor module, and that allowed actually two things that I'll reference. One was governor module, and that allowed vertical teams, so teams like cloud, cyber, data. Every engineer always screws data over because we make changes to the model that we don't tell them, so they're adjusting, broken pipelines, etc. Risk, compliance, legal, marketing, they can all define their policies, and those get converted to policies as code and injected at invocation time into the coding agent, either via hook or MCP. Similarly, horizontal teams that are doing the actual code can define their particular teams, style guides, etc., and that gets injected at invocation time. And so now you have a control plane that sits over everyone's coding agents that is getting injected at invocation time, the various policies of various parts of the organization, and this is what I call giving agents good steer. The engineer can do good steer for sure, but when time crunch happens, they're probably not thinking about the 150-page documents that is sitting there in Confluence that define our cybersecurity mandates and how we do. And the agent definitely is thinking about that. But if we define policy as code and inject it at invocation, all of a sudden that shapes what gets delivered to be more organizational shaped. And that can, include things like how we deploy, what cloud infrastructure we prefer, how we like to secure APIs, etc. Then, and then since you have that policy as code, it's very easy to then reassert it at CI. And so you can virtually guarantee that what it needs to be the shape of code for your organization ends up getting delivered in a fairly similar shape to what you need for your organization, because you've worked collaboratively as a team, and if that changes over time, or each of those teams can own that vertical injection. The other piece is coding agents are very good at working on the individual code base that you are in. And so if you open up, a GitHub repo and it looks at it and it's able to reason over it, and that's great. The problem is organizations very rarely have a single code base. NIB had 3,600 plus repos. And you make a change in one of those repos, there's a high potential that there's going to be an upstream or downstream impact, to at least data or another consuming service. And so we need a way to give visibility to the coding agent for repos that sit outside the current thing you're working on, which you may not even know as an engineer you're making downstream impacts. Mm-hmm. And so something that I built, which I called Skynet, rather ominously, ingest all the repos into a knowledge graph, created vectorization, and extracted code intelligence, a code intelligence database out of that as well. And so gave the agents, the coding agents of the engineer, a 360-degree view of all the other repos that it could pre-calculate downstream impact and upstream consumption before it made a change. And so, neither of those are cheap things to build, and there are some examples of these, like SourceGraph has something like that for the Skynet example. But organizations need to start thinking about how they shape that meta harness to create good steer for the coding agents to make organizational shaped code, not just code in general.
Yeah. Clearly, you are a huge fan of Star Wars and Terminator, so we are definitely aligned there. Look, and I think one thing you said, and if I had to summarize, is in the traditional software engineering, most of those control planes, in a way, were more reactive, in the sense that you build a code, then someone will go through a security governance review. You will go through any other different types of reviews, but that's typically much more reactive. as in the AI world, when you are talking about the 10x engineer workload, the work is getting accelerated, you need to shift from reactive to more runtime controls, right? And that's where that harness becomes important. That it has to be more runtime than being reactive.